All right, for Algebra B today, we're going to take a look at our 6.3 notes. So we're looking at our third and final quadratic equation form. So just as a review, we've had standard form, which is what we're probably most familiar with since we used it for factoring as well. So we had ax squared plus bx plus c. And then we also had factored form, which is what we turned this into when we factored. And that was a, and then the binomials or factors x minus p times x minus q. Okay, so those are two of our forms ready. Today we're going to take a look at our third and final form. We are going to skip over this first part here, so don't worry about those three questions. It kind of walks you into what the form looks like, but we're just going to have you write out the form right away. Okay, so our vertex form of a quadratic is y minus k equals a, and then in parentheses x minus h squared. Sometimes in math, there are mathematicians, teachers, people who write the textbooks, whatever it might be, that want to try to always get y by itself to say something is perhaps simplified. We've all seen that as a direction before. So sometimes when we have this could be written a little bit different where we move the k over. I try to go through and fix it so that it always looks like our original one, but sometimes it is going to be plus k on the other side. So just to be kind of aware, it is also vertex form. It is the same thing. Okay, so what does vertex form all tell us? Some characteristics. The first is that it actually tells us the vertex, which is really helpful because on all of our other formulas, we've had to find the vertex. So now it's telling us exactly what the vertex is. Your h value from your equation is really like your x coordinate. The k value from your equation is really like the y coordinate. It then also tells us the axis of symmetry. It always has to be x equals your h value. Your y-intercept is still going to be wherever x equals 0, so it's always going to be 0, comma something, right, that we fill in. X-intercepts now are always going to be something, comma 0. And we do talk about something called the shift. Originally, we talked about how parabolas are all transformed from the original y equals x squared. So now the vertex is just describing that shift. So it's h units right or left if it's a negative number, and k units up or down if it's a negative number. Okay, so let's take a look. If I give you this equation, I'm just going to write our general form above it. So this is really y minus k equals a times x minus h squared. We're just going to match things up. So notice that the original is subtraction, and so is this. That means your y value is really positive 6. Notice this is subtraction, still subtraction, so your h value is really positive 2. So if I pull out that information, that gives me my vertex. The other thing we can find then is the axis of symmetry. Axis of symmetry has to be your x value. So the axis of symmetry is just going to be 2. If I look at my a value up here, the a value is negative 3. That tells us a lot. It tells us it opens down. If it opens down, it tells us it has a max. And then we could also revisit our wider, narrow, or the same situations. Negative 3, if I take the absolute value of that, it's 3, which is bigger than 1, so it's going to be narrower. The last thing we kind of talk about then is the shift. Okay, so the shift is really just explaining, right? You're just describing how you moved from 0, 0. Okay, and you just use the vertex. So if I wanted to use the vertex up here, I would say since this is 2, the shift would be right 2. And since it's positive 6, then it would be up 6. And that would be kind of how we describe our shift. Okay, let's do another one. Let's take a look at picking out information. So again, our general form, I'm just going to write above it. So if I want to find my vertex, I'm going to pick out my h and k values. Okay, so h here, Well, now it turned into addition in the equation, which means originally we had to plug in a -3. This is still a negative, so this really just means 1.5. Okay, axis of symmetry then has to be the x value from your ordered pair. So axis of symmetry has to be at -3. And we could also talk about the shift with this. If I want to talk about the shift, this means it went left 3 units and it went up 1.5 units. Take a look at the A value. Since A equals 0.5, that's positive, so we know it's going to open up. If it opens up, it means it has a min. And then we would say for wider, narrower, the same. You take the absolute value, which is still just 0.5, which is less than 1, so this would be wider. We'll take a look at 2 more, just kind of pick out some special case situations that might happen in example 4. So here I have y plus 2 equals -1. We don't have to write the 1, but it's a -1 times x plus 5. So the first thing I'm going to pick out is my vertex. So since this is a +5, it means my vertex really happened at -5. Since this is a +2, that means my vertex really happened at -2. Axis of symmetry then is always your x value from your ordered pair. If I want to describe the shift, I'm using my vertex as well, so this means I went left 5, and I went down 2 because it's a -2. And then my A value. The A value up here was -1. That is negative, so we know it opens down. If it opens down, it has a max. And then since it is 1, this would be the same as y equals x squared. Take a look at example 4. Notice we don't have the parentheses. So if I were to write this out, y minus k equals a times x minus h squared. This would mean the same thing as if this was x minus 0 squared. So that's kind of how it looks whenever we're subtracting a 0. So now our vertex, now that I rewrote it, this would be at 0, -0.25, which means my axis of symmetry is going to be at 0. And for the shift, I would just say it went down 0.25 units. Okay, it didn't go left or right because we kept that as 0. Talk about the A value. The A value here is -5, so that means it opens down. If it opens down, it means it has a max. And this one here, since it's 5, this is going to be narrower because that is bigger than 1. Okay, so just kind of picking out some of the information from our equation form. Let's take a look at graphing. Graphing vertex form is the easiest form to graph out of because it gives you your vertex. Okay, as long as we can remember to take the opposite of what we see in the equation, it is telling you right away to fill into our t-chart. In the middle, we want to put that vertex. So this would really be 3, the opposite of -3, -4, because we want the opposite of what we see in the equation. Okay, you can write that up here as well. 3, -4 is our vertex. Then we just use the t-chart by plugging in x values. So I'm just going to count. If this is 3, I'm going to count down and use 2 and 1, and I'm going to count up to go 4 and 5. I'm then going to substitute these in, remembering that there is symmetry between these y values. So if I substitute in 1, I have y plus 4 equals 1 minus 3 squared. 1 minus 3 is -2. -2 squared is +4, and then I need to subtract 4 over. So I really get 0 for both of these. Okay, and then I'm going to substitute in 2. So I have y plus 4 equals 2 minus 3 squared. 2 minus 3 is -1. -1 squared is 1, and then I'm subtracting 4 over. So 1 minus 4 gives me -3. That has to be true for both of these because there's symmetry. I have 5 points, so I can go ahead and graph it. So I have a point at 1, 0, 2, -3, 3, -4, 4, -3, and 5, 0. I do not need to draw in the axis of symmetry when it's in vertex form. You can if you want. You could put in your axis of symmetry, but you do not have to. So here's kind of the steps for that. You want to pick 2 other values, left and right of your vertex. You're going to plug them into the equation, and you're going to solve for y. Graph them, and then you can graph the reflections of them. All right, 2 more graphing problems, and then you'll have some practice to do on your own. So here I want to graph y minus 1 equals 2 times x plus 3 squared. So the first thing I'm going to do is I'm going to find my h and k values, and I'm going to put my vertex in the middle here. So this is really -3 for x. This is really a +1 for y. Then I'm just going to count. So I go down -4, -5. I go up -2, -1. And I plug those numbers in. I'm going to actually come down here and plug in -1 first. Plugging in -1, I have 2 times -1 plus 3 squared. Well, -1 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. And then I add 1 over. So I get that both of these have to be 9. Then I'm going to substitute in -2. I'm going to show all my work. So I get 2. -2 plus 3 is 1. 1 squared is still 1. 2 times 1 is 2. If I add 1 over, I get 3 for both of these. So I have -5, 9, -4, 3, -3, 1, -2, 3, and -1, 9. Or you can make your parabola. Okay, last one together as an example. Here, notice this is my h value, but notice over here my k is actually going to be 0. It'd mean the same thing if I wrote this out as y minus 0 equals 0.5 times x minus 4 squared. So now for my vertex in the middle here, I take the opposite what I see. So this is really 4, 0 is where I'm looking at for my vertex. And then I just count. So this is 2 and 3 and 5 and 6. I'm going to substitute those in. Okay. I'm going to plug in 6. I'm going to come back down here. So I have y equals 0.5 times 6 minus 4 squared. 6 minus 4 is 2. 2 squared is 4. And then I'm taking half of 4, which is 2. So if this y value is 2, I also know there's symmetry, so I know this 2 has to go with the x value 2 as well. Then I'm going to plug in 5. I have y equals 0.5 times 5 minus 4 squared. 5 minus 4 is 1. 1 squared is 1. Half of 1 is 0.5. So both of these have to be 0.5. So I get a point at 2, 2, 3.5, 4, 0, 5, 0.5, and 6, 2.